we're looking at two types of surveys, offset and radial surveys. One of these is not new. We have already done one of them. Which one is it? We've done offset. So offset is where you measure diagonally across the block of land, and then every time you see a corner to the left or the right, you measure at a right angle out to that corner. So we're going to put an example of that just to remind ourselves what was involved in it, but it is not new. We have seen it before. Often we would write a summary, which was called a notebook, and we converted that notebook entry into the actual diagram. So for example, you might have had something that looked, oh, let's not write in red, something that looked like this. Why is it not swapping to blue? Write in blue. Okay. And we would have numbers up here. We'd start with 0, and then it would have something like 15. And what that meant is that 15 metres across the diagonal, there was a corner to one side. For example, it might say there was a corner 7 metres over here. Then it might say 32, and there was a corner over here 12 metres away. At 40, there might have been a corner over here 18 metres away, and then the block of land ended at 50. We need to be able to convert that into a diagram. So to start off with, we're going to draw the line up the centre. It's going to be 50 long. Often we did these to scale, so we might have made it 5 centimetres or something. So that's my line up the centre. 15 along, I need to draw a line 7 metres off to that side. So let's say that this is 15 metres up here, and so I'm going to have a line out there that's 7. Now from 15 to 32, how far have I gone up? 17. So I don't write 32 on this section, I write that that is 17 metres, and then I've got a line out here that is 12 metres. From 32 to 40, how far have I gone up? Just 8. So let's say that's 8. I know this is not to scale. And this time I'm going out 18. And then from 40 to 50, I've got 10. So if this was a scale diagram, I would have lost a lot of marks. That's appalling. But this is not a scale diagram for this particular case. I then would join up the corners of my block of land. Once we had our diagram, the question then asked us one of two things. It either asked us about the perimeter of the shape or the area of the shape. What rules did we use to calculate the perimeters? Pythagoras. So for each triangle, we used Pythagoras to calculate each distance. We had to be careful with this distance. What we did for this one is we created a right angled triangle here. When we create that right angled triangle, remember the height, Aaron, the height is still 8, but this distance here is the difference between 12 and 18, so that would be 6 there. And we used Pythagoras there, then we added them all up. The other thing we did was the area of the shape. Tim. When calculating the area, it was a combination of triangles and trapeziums. So remember, the trapezium is a half times height times a plus b. If you forget that, it is on your formula sheet. The area of a triangle is not on your formula sheet, but you're pretty good at that. It's half times base times height. How many different triangles would I use to calculate this area? 3. Even though there it could be 4, 1, 2, 3, 4, it's a lot easier if we just use this as one big triangle with a base of 50 and a height of 7. Okay? Make sure that you know that you're using all the base. So you're adding all those numbers together for the base of that triangle. So does everyone remember these offset surveys? Yes. Okay, so let's go on to look at the new type, which are radial surveys. Now, radial surveys are given two different ways of showing the information. So radial surveys can be shown as a plane table survey or a compass survey. So let's start with plane table. There's are the names of them. So a plane table. Okay, so it's a bit of a weird name. So plane table radial survey is the first one we're going to look at.
Please have your plane table stone or take.
Okay, this is not the table you have on a plane. What happens is that you imagine you get a table, a physical table, you go to the middle of your field and you put your table down. And from there, you measure from the centre of that table, your piece of paper on the table, how far away each corner of the block of land is. Okay? And what direction it would be. So, for example, I walk to my middle of my field, I put a table down, and then I put a dot in the middle of my piece of paper. What I then do is I say, okay, there's a corner of the block of land over there. It is 50 metres away. Alright? Then I say, oh, there's another corner over here, and it's 40 metres away. There's a corner over there that is 80 metres away, and there's one over here that is 30 metres away. So I've measured to the corner of each block of land, each corner of the block of land. What I then do is I also measure the angle between these lines. So for example, this one here was 50 degrees. Alright, this one here, say that's 100.
Wouldn't it be 130?
It would be 130 if that was a straight line, but there's not quite a straight line. Okay, my diagram is not awesome.
No,
I'm sure yours could be a little bit better than mine. Pardon?
40 and 80 are the same length. At 40 is longer than 50, but that's okay.
Okay, you want my 40 to be a bit shorter, do you? Is that better?
That's a bit better.
You happier with that?
Just a smidge.
And you want this to be 60 degrees, do
80
you?
has to be longer a little bit.
Okay, just stop picking up my diagram. Okay, so we've got 150 there. Let's say this is 130. What would this one have to be?
360 minus the sum of your...
So putting those together, I've got 280. So 360 minus 280. 80 degrees. Okay? And this is now my picture. Alright. Okay, that's my plane table radial survey. From this, I can calculate again the perimeter and the area. Guys, if I'm going to calculate the perimeter, I need to work out each of these distances. Let's give them some letters. Each of these I can calculate using what rule? Okay, so last time I was using Pythagoras. What rule am I using now to find the distance AB? The cosine rule. Well done. So, to use the cosine rule, let's just find AB. So this distance here is going to be AB, and it's going to equal 30 squared plus 50 squared minus, too much chatting, Aaron, 2 times 30 times 50 times cos, that's not going to quite fit, cos 50 degrees. So I grab my calculator, I type it in, 30 squared plus 50 squared minus 2 times 30 times 50 times cos 50 again. Okay, I got 1,471. Is that my answer? No. What have I forgotten to do? I didn't square root it. So I need to square root my answer, giving me to one decimal place, 38.4. And what I would need to do is I'd repeat that 3 more times to find the entire perimeter. What rule would I use to find all the areas? What is the area rule? Half AB sine C, because there are no right angles here. I can't use half times base times height. I'm going to have to use the rule that it's a half AB sine C. So just for this triangle for now, to calculate the area of that would be a half times 30 times 50 times sine 50. So on the calculator, I do a half, times 30 times 50 times sine 50, giving me an area to one decimal place of 574.5. Make sure your units are meters squared for area. And to find the area of the entire block of land, I would have to repeat that 3 more times. Now the last one we're looking at is a compass radial survey. Now these are almost the same. They look very similar, except instead of measuring the angles between each of the lines to the corners, it gives you the bearings of them instead. And then we need to calculate for ourselves what the angle between them would be. So for example, if I've got a line going off here for 180 meters, a line going off here for, let's make that 210 meters. Let's say one here and one there. What you would be given, quiet, we'd be given the length of each of those. So I'm putting a lens in afterwards to make them about, so let's say 175, and this one would be about 260. They're not going to give me the angles at the centre this time. They're going to tell me the bearing of each of the lines. So this one here, they might tell me the bearing of that one is 35 degrees. The bearing of this one might be 89 degrees. Bearing of this one, let's say that would be around 206 degrees. And this one up here, let's say that's around 330. You want to go? Oh, that's like maybe 310. Oops, 310. So it gives me the bearing of each of the lines. That's fine. We can use those bearings to calculate each of these angles at the centre. So these 3 are quite easy. You just subtract your bearings to find what the angle would be. So if I've got the difference between 89 and 35, what's that going to be? 89 minus 35? Come on, Tim.
54.
How many people are giving us
54 minutes.
That was close.
Okay, so this is 54. What about this one here? So these are easy, 206 minus 89. This one here, I cross 0. So when you cross the north line, watching this last little bit please, Charlie. Because you have north in here, you've crossed this line. I need to calculate each of those separately and then just add them together. So this bit on this side is going to be 35. On this side, I have 310 up to 360, which would just be 50. So together, that makes 85 degrees. Once I've calculated that, it's just the same as the plane table radial survey, and I can calculate the distances using the cos rule or areas using the half AB sine C. Okay, that's it. Which one? 50, because that was 310, and I know north is 360. So I did 360 minus 310, that gave me the 50, and then I added them together, and I'm done.